All right, so for question number 1 here, we got a velocity versus time graph. Okay, a velocity versus time graph. If I want to find my displacement, I need to take average velocity and multiply by time. Okay, in order to do that, I'm essentially finding the area underneath the line. Okay, so for this first triangle here, okay, this first triangle has a height of 60 and it has a base of 10, so 60 times 10 over 2. Give them a mark if they showed that. Okay, then they got to find the area of this rectangle next to it, which has a height of 60 and a base of 5. So if they had 60 times 5, give them a mark. Okay, if they had, for this last triangle, height of 60, base of 15 over 2, okay, give them a mark for that. Or maybe they just showed those numbers, what those come out to. That's fine as well. Okay, the total area, and thus displacement of the object, is positive 1,050 meters. They must have the positive. Displacement is a vector quantity. Okay? It's not half off. If they don't have the positive, the answer is not right. They can have the marks for the other calculations, but not for the answer without the positive. Any questions? Okay. Second one. Okay? Second one is a position versus time graph. If I want to find average velocity, I need two things. Total displacement and total time. So if they showed that they would have to do that with this formula here, you can give them a mark. Okay, so we're dealing with this here, v equals d over t right now. Okay, our initial position is right here at 0 meters. Our final position is here at negative 20 meters. That means that our overall displacement is negative 20 meters. That took 9 seconds. Okay, so if they have negative 20 over 9, give them a mark for that. And the final answer for their third and final mark is negative 2.2 meters per second. Okay, I'll give a little leeway. If they had negative 18 here and then it would have been negative 2, I will also accept that. Okay, we'll say, you know, reading the graph was difficult. We'll give you that one. All right. So 3 marks for that one there. They must have the negative, guys, though. It's a vector quantity. If they don't have it, it's not right. Okay, so the whole thing is out of 7 marks. Please give them a mark out of 7. Let them see it. Put it in the box, and then back to your desk. So just follow along here, guys, as we go over the Need for Speed Graphing Lab. Okay, it's going to be pretty straightforward, and you're going to get a lot of it done in class today, provided you stay focused. Okay, what we're going to be doing here is now looking at a lab activity where we're dealing with velocity versus time graphs. Okay, the first one we did was position versus time. This one's velocity versus time. Okay, so the problem we're investigating, the change in velocity of a vehicle is measured over time. It tells us acceleration. Okay, if we do that, if we look at the change in velocity over time, we get acceleration. That's that VF minus VI over T formula that we've been working with. Okay, from a velocity versus time graph, we can also calculate acceleration. Okay, because obviously that's where the formula VF minus VI over T comes from. Okay, it's from a velocity versus time graph. Okay, so our variables. Okay, we're going to be identifying our variables. Now we're not actually running an experiment. Someone has run the experiment for us, and we have their data. That is, they have done acceleration tests of various cars. Okay, the various cars are, okay, down in that chart you see on your sheet. Okay, right here. All right, so the various cars we have. Okay, Ferraris, Corvettes, Vipers. We even have the Beetle. Okay. We have Toyota Corolla on there, just so that you had something slow. All right. Anywhere where you see NA in that chart, you will not have a point, because there simply wasn't any data available, or the car was incapable of reaching that speed. Now, obviously, that's not the case for the Charger here, reaching 18 meters per second, because I just couldn't find data for that. Okay. But obviously, for like the Corolla and the Beetle, all right, they just didn't bother trying to get them that fast because they didn't have 2 weeks to do this. Okay. All right, so what we're looking for here, guys, are the variables. Now, if we're in a lab where time is a variable, time is usually which variable? Manipulated, because it usually goes on which axis? Yeah, that's where the manipulated variable goes. Yeah, x-axis. All right. If we're doing velocity versus time graphs, I don't think you've ever seen one where time wasn't on the x-axis. Agreed? Okay, so the other thing we're looking at here, the other variables, okay, would be velocity, okay, and then any other variables that would be involved in testing cars on a racetrack, okay, things like weather, tires, um, fuel level, driver, okay, things like that, anything that could affect, okay, the rate at which these cars accelerate. All right, everyone with me there? Okay, so you guys have got to decide where those variables go. We're going to have to say, we're assuming here, we're kind of designing this experiment a little bit ourselves, so we're going to identify what we think good controlled variables would have been for that experiment. Yeah. Okay. So for the procedure here, okay, you're going to select 5 cars, okay, and for each car, you're going to create a graph of velocity over time. That means you're going to have 5 graphs. Okay, there just doesn't seem to be a way to do this lab where we can get all the cars on the same graph because their times are not the same. Okay, so what you're going to do is make a graph for each of your 5 cars using Google Sheets, just like we did before. All right, everyone follow me there? I'll run through a really quick review of how you do that. Okay, so you plot those points on your graph, okay, and then you're not going to use slope equals rise over run. You're going to use, what does Google Sheets spit out for you? Y equals mx plus b. Remember that y equals mx plus b, when Google Sheets spits it out for you, gives you m, right? It tells you what the slope is. Now what you have to remember is, what does that number represent? Okay, on a velocity time graph, what does slope represent? That's going to be something you're going to need to know when you're doing the analysis here. Okay, so you're going to essentially just write those in. Okay, so you're going to fill in this chart. Your chart will have 5 rows on it. I think the one I put on Google Classroom does have 5 rows on it. Okay, so you'll fill it in. Okay, and make sure here where I have units, 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 you put in the real units. Okay, don't leave units in here when you hand in your lab report. You need to put in the units, okay, for each one of these things. Everyone follow me there? Okay. Okay, so you're going to do the change of velocity. Yeah, actually, you won't have to do that because I've changed the chart, but I forgot to change the procedure here. So you're going to graph the 5 cars, and you're going to fill in this chart. Rank them from fastest to slowest based on their acceleration. All right, not based on the data in the chart, based on the accelerations you get from your graph. Does everyone follow me there? Okay. All right. I mean, you might just want to write that on that sheet so you don't forget it. I'd love to write it up here, but my pens don't work today. Okay. Displacement to 45 meters per second. That's another thing you're going to have to calculate from your graph. Okay. You will have to calculate the displacement to 45 seconds. Now, we just had a question on our quiz about how to calculate displacement from a velocity versus time graph. Okay, so you need to be mindful of how you did that. Hopefully you did it right on the quiz. Okay, if not, definitely do it right here. Okay, and get that. Now remember, you got to look at your equation that Google Sheets spits out for you. If your y-intercept isn't 0, okay, you may have more than one shape. Is that a big enough hint? Okay. What I mean by that is something like this. Here's my graph, and my line goes like this, and my y-intercept doesn't end up being 0. Okay, that might mean that I have more than one shape to deal with. Okay, hopefully that's a big enough hint. I'm not really happy with myself for giving you that hint. Actually, I feel kind of bad now. Okay. All right. So big things down here in the analysis. Obviously, filling in the chart is the big part of the analysis. Okay. From your data, which of the cars accelerated the fastest? So basically, looking at your rank here. Okay, and you just rank them 1, 2, 3, 4, 5. Okay. Tell me which one accelerated the fastest. Just write that down. Okay. And then using your best fit line. Calculate the displacement of each car and reading 45 meters per second. You need to show your work here. All right, so show me how you did that. Show your work here because that's worth marks. Okay, and then fill in the numbers in the chart. Okay, questions on what you're going to be doing there? All right, sorry, I missed the hypothesis. Got to go in here and forgot to do the hypothesis. Okay, so for our hypothesis, we got to talk about essentially how we can get the acceleration of a car from this kind of graph. Okay, so if data can be interpreted from a graph, you maybe don't even want to start it that way, but maybe if you want to say something about what acceleration is, you could even use that as the if part. Okay, say if acceleration is this, and data from cars accelerating is graphed, then acceleration can be found, okay, in whatever way. Okay, something along those lines will be fine. Okay, questions on what you're doing there? All right, now I'm just going to quickly outline here again what you do with that graphing thing. Okay, so what I've done here, guys, in your Need for Speed Lab is I have not given you a Google Sheet file, right? Because there wasn't any point to that. You can make them on your own very easily, right? So you'll have obviously your file that you always fill in eventually. Okay, so here's your file. Like I said, I gave you the chart with enough rows in there. Here's the data chart right here. Right, so you have a copy of it as well. So what you'll need to do in order to make a Google Sheet, okay, is go just to Google and then go to your drive and click either Create or New, depending on which version of drive you have. Okay, and then just make a new Google Sheet. You're not going to hand in this Google Sheet. You're just using it to make the graphs. You're inserting the graphs into your lab report, same as the last lab. All right. Which column should have time in it? The first one or the second one? First one. Because whatever you put in that first column always seems to end up on the x-axis by default. Okay. So make this one here time. Okay. And this one here speed. Right, and then fill it in. Now, remember, you're going to need to you can add a new sheet each time you want to make a new graph by pressing here on this little plus button at the bottom, because you're going to need a new sheet, essentially, for each car, so that it keeps the graphs separate. All right, everyone follow me on that? So if I'm graphing the Ferrari first, I'd put in the Ferrari's time data, the Ferrari's speed data, okay, and then I'd add another sheet. 5. Okay, something happened there. So I'd put a new sheet in. Now I've got sheet 2, okay, and I do the same thing and make that one for the next car and so on. Again, you're not going to hand in this file. You're just going to put the graphs you create from it, okay, into your Google Doc. Remember, when you want to make the graph, you go to Insert, okay, Chart, and then you pick Scatter. Because I don't have any data, it doesn't know what to do right now, okay, but you click on Scatter, pick the top one, okay, do your best fit lines, all that kind of stuff. If you run into trouble, you don't remember, okay, just come and see me and I'll explain it again. Because we want time on the x-axis, the way the data is set up, time wasn't the responding, or time was the responding variable in the experiment they ran. There's no way around that. So we don't want it to be that way. We don't want time on the y-axis. We want time on the x, so we have to do 5 separate graphs. Otherwise, it just gets really confused, and it makes a terrible mess of the graphs. Okay? Unless you really have a lot of time, and you want to figure out how to do it. If you figure out how to do it, you can come show me. Okay? It won't hurt my feelings in the slightest. All right? Okay. Grab yourself a Chromebook. Okay, due date for this, guys, is going to be December 2nd. That's Tuesday. Yeah, Tuesday. Just in case you've forgotten how to do the graph, okay, so I've entered the data here for the Ferrari, I think. Okay, so I go to Insert, and I go to Chart, okay, and I go to Charts up here, and I pick Scatter, click on Scatter, and it gives me those points. And obviously, I want to edit things like the chart title, okay, and all that, and I do that in Customize. All right, so when I click on that, I'm going to call this Ferrari F40 velocity time. Okay, and then, okay, my horizontal axis, you want to give that a title, time in seconds. Okay, and guys, I would recommend on this graph that you show more grid lines. Okay, it's going to make some of your calculations, like the one you have to do for displacement, it'll be a lot easier if you have more grid lines. So one of the things you'll want to do is when you're in the customize part here, go down to minor grid lines, okay, and I would say put them in every one. And just type in one because it's not one of the options. No, maybe it won't let me do it. Okay, so put them in every two just so you get more grid lines, and then do the same thing. Do the same thing for the vertical axis. Okay, so speed in meters per second. Okay, put in your minor grid lines. Okay, just so you get a few more. Okay, and then once you've got that, okay, you'll want to go down to trend line, and it's at the very bottom. Okay, make it linear. All right, and you can see what happens with it. You do have a y-intercept that is something other than 0. Okay, so that's going to be meaningful, okay, later on for you. And then remember that you get more options after that. You want your label to be the equation, so it puts it in there. Okay, then you should be good. You can insert that, okay, and then copy it over, okay, into your lab report. Okay, so you go copy, okay, and put it in here. Okay, so where should those graphs go? Maybe right here where it says insert graphs below. That's it, yeah, it's tricky. Alright, so I mean you're just gonna have them kind of one under the other. Just make sure, guys, that you title them, okay? Because if they don't have titles and I can't tell which car it is, it's gonna make it very hard for me to check your work. Okay, which is gonna probably affect your mark negatively. Right, so make sure they have good titles, good axes, okay, and they look sharp.